Okay, everybody, I thought it'd be good to make another video to go over some things in a recent quiz. And that is just, say, assortment of problems that involve calculating the derivative. Okay? So, with this first one, I think it's pretty straightforward on what it's asking, but you have to know how to use the rules the right way. Okay? So here's summarize what it's asking first. So we have a curve and we have a point on the curve. The point's 2/3 for t, and if you put 2/3 for t and you multiply by 4 and you divide it, you do all that, you'll get 53/8 for the second coordinate for f of t. Okay, so you got a curve and you've got a point on the curve, and then the question, fairly straightforward from there. What's f prime of 2/3? Or another way to think about that is, what's the slope of this curve at that point? How steep is it at that point? Okay, that's what we mean by slope. So how about this? First of all, we've got this rule for derivatives, and it goes something like this. If y is, let's use y and x. So if y is x to the n power, then y prime is n times x to the n minus 1. It's a pretty easy rule to use on its own. I mean, if the problem doesn't look like the rule, well, then you've got more issues. But, at least if we can get to here, then we should know what to do. So the way that I would think about this rule is I'd say, well, it needs to be like the variable, the independent variable, whether that's x or t, to some power. Not 1 over the independent variable, but just whatever the variable is, to some power. So let's rewrite f of t a little bit. We'll say f of t is, now we have to know a fair amount of algebra to do calculus successfully. So let's say I know enough algebra that I can rewrite what I'm given this way. It's 7 minus the number 1/4 times t to the power -1. And that's like how I needed it. Now, there are other rules besides this one. There are rules about what does this constant play into the procedure, and what about that constant? But we'll talk about it. I have it the way that I need for the most part. Okay. So, okay, f prime t. We're at the point where the rules are applicable. So one term at a time. So the derivative of 7 is a constant, so its derivative is 0. And then we would carry down the minus, all according to the rules. And we would carry down this constant. Here we have a constant times a variable. So in that case, we carry down this constant factor of 1/4. And then we apply our rule to this variable expression t to the -1 power. What is the derivative of t to the -1 power? Well, that's contained up here. It's -1 times t to the -2 power. Okay, so we've got our derivative. F prime t is, well, you have 0 minus -1/4 times -1. Let's write like this. That's going to be positive 1 over 4t squared. Okay, so there's our derivative. Now, the question was a little bit beyond that. What is f prime at 2/3? What's the slope of the curve at the point where t is 2/3? So, well, that is just a matter of putting the number in. And t is 2/3. All right, let t be 2/3. Get 1 over 4t squared. Wouldn't that be 4/9? Yeah, that'd be 4/9, 2/3 squared. And so this is going to be 16/9 if you multiply together. So it's going to be 9/16. That's how steep the curve is at that point. All right. So, that's how you do it. We could stop thinking about it if you want to, but it's sort of like, if I could zoom into the curve, like on a very small scale, Like, so the curve, like, the big picture is it's wavy and it's curved. But at, at a microscopic scale at that point, if you look very close to the point, then, you're going to see this rise and run proportional to like 9 to 16. That's what it's going to look like, very close to the point where t is 2/3. That's what we mean when we say, what's the slope of the curve at that point? So maybe right there, that's the point where t is equal to 2/3. And it will look roughly straight, very close to that point, with these proportions for rise and run. Okay, so, all right, we got that one. That one's not too bad, but there's some things to think about along the way. This one was on the quiz, and it's considerably harder, okay? Because, one, there's some thinking and understanding that has to happen, and then on top of that, the algebra is pretty difficult, I think. All right, maybe I'm just having an off day and I can't think of smart ways to do things. But I thought the algebra was difficult. If you think of an easier way, let me know. Anyway, so let's say that here's what we're given to wrap our head around. So it says, solve for k such that the line is tangent to the function. Now that doesn't sound too bad. You got this line, you got that function. What's k to make this line tangent to that function? All right. So that's what we're after. Now, I think that, some people are real good with their imaginations and they can just start writing equations down and solving them, and that's about all that happens. Most normal people, though, need to see something. So I'm going to say, let's imagine the problem like this. So here's this curve. F of x is k times x to the third power. And I don't know what k is, right? That's the whole idea. And then there's this tangent line to it, all by the assumption of the problem. And it's known to be y is equal to 5x plus 6. Now, there is a point where the tangent line meets the curve. That's what a tangent line is. Meets the curve at some point. What point? Well, I don't know. It doesn't say. We don't have that much information yet. So we'll call that point A. And I think that all of our math is just centered around what happens at that point. All right? So here's what we know. So let's say this. At point A. Let's just write down what we know. As you go forward doing math in subjects that are related and involve lots of math, some sciences, most engineering disciplines, so on, then you might not know how to solve the problem. You're just gonna have to start writing stuff down that you know, and then maybe it'll come together how you figure it out, right? So that would be an important skill for you to learn, I think. All right. So here's what I know at point A. Let's write like an itemized list. So 1, isn't f prime x equal to 5? Would that be true? Yeah, because the slope of the curve is the same as the slope of the tangent line at point A. I've done this before in other videos, but if I could cover up the rest of the picture, you can't really tell them apart because they blend together. The slope of the curve is the same as the slope of the tangent line at the point where they meet, at the point of tangency. So what's another way to say this that will help us solve for k? Well, so there's f of x. It's k, some constant, some unknown number, times x to the third power. I could find f prime. If k is a constant, I don't have to know what it is. Wouldn't it be 3 times k x squared? Isn't that what our rules for derivatives would tell us the derivative is? So you bring the k's a constant, bring the power down, 3 times k, take 1 away, square. So that's got to be 5 because that's the slope of this tangent line that meets it right there, right? 5's the slope. 5's the slope here on the curve. Okay, so we get that, and I want to know, I need to know something about point A. So I would like to know what's the x coordinate and what's the y coordinate. Okay, so I can tell you the x coordinate here. So x is, imagine if I divide by 3k and then I take the square root of that, then I'll get the square root of 5 over 3k. All right, so now I know something. Okay, so point A has an x-coordinate of root 5 over 3k. And it has a y-coordinate too, but I haven't found that yet. But it does have one, right? I mean, all points do. All right, so how would we find the y-coordinate? Well, how about this? Isn't the y-coordinate for this point on the tangent line in red the same as the y-coordinate on the curve? That is true, right? I mean, look at it. That's why I drew the picture. You can tell they're the same. So I can't really find the y-coordinate on the curve, but I have the equation of this line. So if I knew the x-coordinate, I can find the y-coordinate. All right? So imagine this. Imagine you put this x in there. You would find the y-coordinate here. And that's what I would like to know at this point. Okay? So we'll do this. We'll say y equals 5. Okay? And then the x-coordinate is root 5 over 3k. Right? So 5x and then plus 6. All right. Now, I'll write that a little bit different then. Okay, maybe just I'll say like 5 root 5 probably. Yeah, let's do that. So that's 5 root 5. Okay, over root 3k. Okay, and then plus 6. All right, there we go. So I know something about that point. I'd like to know more than that, but you know, that's as much as I can figure out for now. I found the x-coordinate. I plugged that value in here to find the y-coordinate, and there it is. So there's the x and y coordinate. The x and y coordinates don't look real good. They look complicated, and I think that's what makes this problem hard to solve. Now, here's how we can solve for k. Isn't it true, going back to the information that we have, that if this point is known to be right there, it's also true if you put this x in there, then this is what you get for y. So I've used the fact that both this point is on the tangent line, and now I'm going to use the fact that it's also on the curve. So think about it. What would it look like if it had to be true that when you put this x in there, this is what you got for y? So think about it for a second. What would that look like? Also, the equation is y equals kx to the third power. So let's see. Y, 5 root 5 over root 3k plus 6 equals k times x. So that's x, right? 5 over 3k to the third power. There you, I mean, that might look ugly, and you're not looking forward to solving that, I'm sure, but that's what it says. Okay? You put this in for x, kx to the third power, you get this for y. Why? Well, that's the point that's on there. That's why. Okay? All right. So now about solving for k. So my job now is to solve for k. And that is like a crazy understatement to say that, well, this is not enough room to solve for k right there. So I did it on another page, just anticipating running into this problem. So here's basically where we are. We're going to solve for k. It's not real easy to do. Okay, but I'll walk you through the steps. It involves knowing quite a bit of algebra, especially laws of exponents. Okay? So this is what we had, all right? And I thought, well, maybe it would be good if I expressed everything in here in terms of an exponent. So everything here has an exponent of a half because of the root. And so on top of that, it's going to have an exponent of 3. And so the rule there is to multiply the exponents. And so you get like this. Okay? All right. Then I thought I would collect some of the like terms, like, 5 and 3. Those are both numbers. And so we'll say, well, 5 over 3 both has the power of 3 over 2. And then k and k, those are like numbers too. And the rule is when you divide something by itself with different powers, let's say, that we subtract the power. So this would be 1 minus 3 over 2. So that's negative half power for k. Now, also over here, I said, I think I see how I can solve for k. So I left the root 3, and I said, well, that root k, if I wanted to, I could write it in the numerator as k to the minus half. And then that's where I had my idea about how to solve it, because I said, okay, if you had it like that, I can multiply the whole equation by k to the positive 1/2. It would cancel, and it would cancel, leaving a lone factor of k right here with the 6. So it would be like that. Okay. And so now when I was doing this, I was thinking, okay, well, my goal is to isolate that, right? I'm trying to solve for the k. Everything else here is just a number. If I could just isolate the k, then I'll know what it is. So I'll subtract this term, 5 root 5 over root 3. And then these actually can be combined, getting a common denominator of 3 root 3. Okay, hence the 15, and then those are like terms. 5 root 5s take away 15 root 5s will get you negative 10, and like that. And then I divided by 6 at that point, and so you would get 10 over 18 if you did that, but we reduced to 5 over 9. And then I'm almost there. Like, my goal was to isolate the k, and I've got root k equals that number. So now I'll just square both sides. I'll get k equals, and this turns out to be 25 times 5, that's 125, and that's 81 times 3, so 243. So k is 125 over 243. So if you had like a graphing calculator or some online grapher, and you plotted k equals 125 over 243 x to the third power, and say you plotted that, and then you plot this tangent line y equals 5x plus 6, it looks something like this. They'd run right into each other there at that point. And then that would verify solution of the problem, because it just says, like, well, what's k have to be for them to be tangent? It wouldn't be tangent if you had the curve here and the line over there. That wouldn't work. But if you graph it, right, with 125 over 243 for k, they'll run into each other like this and, in fact, be tangent. Okay, so that one is a little bit hard conceptually. There's a lot to think about to even get to the point where you can solve it. And then, well, I had at least me. Maybe you're smarter than me. Maybe you can solve it less steps than that. It took me a whole page. Anyway, how about one more problem? Okay, so this one on the quiz, I think it's not given in terms of a picture. And if you can solve it without a picture, then great. You don't need me. So for everybody else, then I'm translating a problem from the quiz into picture form. Okay, and the problem on the quiz said a curve was given and a point was given. Okay, and it says find the equation of the tangent line. That's basically it. I mean, it may have seemed a little more complicated than that, but if you just made a picture of here's everything I know when I read the question, it would have something like this. You know the equation of the curve, and you know some point that the tangent line intersects off in the distance. But you don't know the equation of the tangent line. What is the equation of the tangent line in red? Okay, so let's talk about how we can do that. Now, let's see. So how about this? Let's start with a premise that I think will allow us to solve it. and we have this point in question. Like I said, I don't know this point, right? I know that there's this tangent line to the curve, and if you project the tangent line out, it happens to hit at -9 on the x-axis, but I don't actually know where that is. So anyway, is it true that let's call this point A. Okay. So is it true that at point A, the slope of the tangent line is equal to the slope of the curve? That would be true, meaning that you can't tell them apart right there. They look the same. All right. What's the slope of the tangent line? Well, so that, there's different ways you could figure that out. One of them is just like rise over run. You remember learning that way back when? That the slope of a line is rise over run. Okay, the tangent line is a line, so that would still apply. And what's the slope of the curve? Well, there's also a way to do that, and it's the derivative, f prime x. Okay. So, well, all right. The derivative, like that's what this recent quiz is based on, is just figuring that out. So if your curve is root x, and you use the rules we've been working on, then you'll get 1 over 2 root x. Okay, so that's f prime. But what's the slope of the tangent line? Well, it doesn't seem like we have much or enough information to work with. Like, I don't have the equation. How am I supposed to tell you how steep that line is? You know? So here's what I'll do. I'll say, well, I do have some points, on here. Right? And, even if I don't know point A, like I know a little bit about it. But with that aside, this is the rise and the run, isn't it? Rise, run. So what do we know about point A? Well, we don't exactly know where it is, but doesn't point A take the form of x for the x coordinate, root x for the y coordinate? That's true, isn't it? So why is that true? Well, because it's right there, and it is on this curve, and points on this curve look like this. The x coordinate is whatever the x coordinate happens to be, and the y coordinate is the square root of the x coordinate. All points on that curve are like that, including point A. So I could find that slope, like rise over run. What's it going to be? Root x take away 0 over x take away -9. Rise over run. Right there in that green triangle. Okay, so let's do that. So rise over run, slope of the tangent line. I got 2 points. Root x minus 0. Okay, and then x minus -9. So that'll be x plus 9. And then so we get that. So that's rise over run, and then that's the derivative. Anyway, so let's do a little simplifying. So we'll just get root x, and then we get x plus 9. Okay, and then over here we'll get 1 over 2 root x. And from here, this is the type of equation we can solve by cross multiplying. So, that's why so we'll get 2x is equal to x plus 9. And then so we'll get x is equal to 9. Okay, so, well, what x? Where? This one. This point. Okay, so here's what I know. Point A right there is 9 for x. And we did say all points on the curve, including this one, are such that the x-coordinate is whatever it is, and the y-coordinate is the square root of the x-coordinate. So that's 9 and 3. Okay, so, all right. So I've got that. Now here's what the question becomes. What is the equation of the tangent line that hits this curve at that point, which is now known to be 9 and 3. So let's do like this. We'll say, all right, there's part 2 of the question. What's the tangent line at the point 9 and 3? So here's how I've showed you how to do that before. First of all, the derivative tells you the slope. And we found the derivative to be 1 over 2 root x. And at that point where x is 9, 1 over 2 root x is 1 over 6. Okay? So the tangent line equation is going to be like this. Y equals 1 over 6 x plus some number b, which is the y-intercepted line. Okay, now we're almost there. So I know the slope. How do I find b? Well, again, this point is on the equation of this line. So I will use the fact that if x is 9, y is 3. Okay, so it's 3. And then this will be 9 over 6 plus b. And 9 over 6 reduces to 3 over 2. So this is 3 over 2 plus b. Okay, and then if you subtract, it makes b is equal to 3 over 2. All right, so finally we have an answer. The equation of the tangent line is y equals 1 over 6x plus 3 over 2. Okay? And I want my final, I mean, I did all this work, right? I want my final answer to this question to stand out. So the equation of the tangent line that's in that picture in red is y equals 1 over 6x plus 3 over 2. Okay. And there you have it. Now, quick breakdown. First, I had to figure out where is this point? Okay? And I used the fact that, well, the slope of the curve and the slope of that tangent line are equal at that point. Slope of the tangent line found by rise over run, given that I'm dealing with those 2 points. Slope of the curve is the derivative. Pretty easy equation to solve by cross multiplying. I figure out this point here is 9 for x, 3 for y. For the tangent line at that point, 9 for x, 3 for y, its slope is 1 over 6, which is what you get if you put 9 into the derivative. That means the partial equation of the tangent line, 1 over 6x plus b. Using the fact that this point's on it, solve for b, and I get my final answer.